In May 2021, a single particle smaller than an atom fell out of the sky over Utah, carrying the energy of a baseball thrown at full speed. One invisible speck, packing 40 million times the punch of the most powerful machine humans ever built. That is not supposed to be possible. Nothing in our galaxy can make it. And when scientists traced its path backward to find the source, the line pointed at a patch of sky that is completely empty. No star, no galaxy, nothing. So here's the question. This whole video is built around something struck our planet carrying more energy than physics says should exist. And if one can reach Earth, what happens the day a stream of them arrives? Hold on to that question, because the answer is the last thing you'll hear. And it's stranger than any disaster. Stay with me, because by the end, you'll understand why serious physicists say this particle may have come from a crack in reality itself. They named it the Amaterasu particle, after the sun goddess of Japanese mythology. It was caught by the telescope array. 507 detectors spread across 700 square kilometers of desert near Delta, Utah. The lead scientist's first reaction wasn't excitement. It was denial. He assumed the machine was broken because nothing had registered an energy like this in 3 decades. Written out, that energy is a 2, a 4, another 4, and then 18 zeros. One particle. And explaining it broke a rule that's supposed to make particles like this impossible in the first place. Hold that, because it's the wall the entire mystery slams into next. Here's the rule. Space isn't empty. The whole universe is filled with a faint afterglow left over from the Big Bang. A sea of ancient light so cold and thin you'd never notice it. But to a particle moving at almost the speed of light, that gentle sea is like a wall of sandpaper. Physicists have a hard limit for this. Any particle traveling far enough through space grinds against that ancient light and bleeds off energy. The further it travels, the weaker it gets. So a particle this powerful cannot have come from far away. It would have lost most of its punch on the journey. It had to be born somewhere nearby. And that is exactly where the problem starts. Because the nearby sky it had to come from was empty. When you trace a cosmic ray backward, you almost always find something violent waiting at the end of the line. An exploding star, a black hole tearing matter apart, a galaxy on fire with newborn suns, some engine big enough to fling a particle that fast. Amaterasu's path pointed straight at the local void, a vast, almost perfectly empty bubble of space sitting right next to our galaxy. No stars, no engine, nothing that could have made it. So now you have a particle that can't have come from far away, because the journey would have killed its energy, and can't have come from nearby, because there's nothing nearby to make it. One of those facts has to be wrong, and here's the part to hold on to, because it only pays off at the very end. There is one reason this particle will never arrive in a group. Always alone, always a single shot. And that single fact is what finally cracks this whole mystery open in the last minute. Keep it in the back of your mind. Because this wasn't even the first time the sky did this. It happened once before, and that one was bigger. Rewind to 1991. A different detector in the same Utah desert caught something 30 years earlier. A particle so absurdly energetic, the physicists who found it gave it a name that stuck in the textbooks, the "Oh my God" particle. Its energy was even higher, around 320 of those same units. To put that in human terms, this is a particle smaller than an atom, moving so close to the speed of light that if it had raced a beam of light across the entire galaxy, it would have lost by a margin almost too thin to measure. A fraction of a second over a 100,000-year journey. For 3 decades, the "oh my god" particle stood alone, and people half assumed it was a glitch the universe would never repeat. Amaterasu proved it wasn't. These things are real. They keep coming, and the two were caught by completely different methods. So you can't blame the equipment. Which forces a colder question. How often does this happen, and what are the odds one is pointed at us? Imagine an ordinary day. You're standing outside, phone in your hand, sun on your face. In that exact moment, particles from deep space are passing through your body, through the screen, through your skull, through the ground beneath you. Constantly. Most are harmless. Your atmosphere is a shield 17 kilometers thick, and it eats almost all of them. The ultra-high energy ones, the Amaterasu class, are mercifully rare. Roughly 1 strikes a given square kilometer of Earth once per century. And the reason it's harmless to you is the same reason it's a nightmare for physics. All that energy dumps into the air far above your head, exploding into a shower of harmless debris long before it reaches the ground. Here's the strange part for you. Watching this. The desert that catches these is in Utah, but the sky it watches is the same sky over your house tonight. The next one could land over any ocean, any city, any rooftop on Earth. So I'm curious. Write in the comments where you're watching from. I want to see how far this map of you stretches, because every single one of you is standing under the same sky that catches these, so one particle won't hurt you. But that was never the real question. The real question is what's sending them, because whatever that source is, it's an engine of a scale we cannot locate, cannot explain, and cannot rule out pointing more our way. And in 2026, scientists went back to the data to hunt it down. What they found only deepened it. Here's where the story gets fresh, because this isn't settled history. It's happening right now. In early 2026, a research team reanalyzed Amaterasu's trajectory with better models of how our galaxy's magnetic field bends an incoming particle's path, like light through a lens. Their new suspect, a galaxy called M82, the Cigar Galaxy, about 12 million light-years away, a furious place where stars are born and die at a frantic rate. It's a better candidate than the empty void. But notice the problem it drags right back in. 12 million light-years is far. Far enough that the ancient light wall should have bled the particle dry before it ever arrived. So the 2026 answer trades one impossibility for another. Either it came from nothing, or it came from too far away to still be this strong. The mystery didn't shrink. It just changed shape. And that pushed some physicists toward an explanation that sounds less like astronomy and more like science fiction. When the normal explanations all fail at once, scientists start looking at the floor they're standing on. One of the researchers on the original study said something out loud that's hard to forget. Maybe, he suggested, we're not looking at a particle thrown by some distant engine at all. Maybe we're looking at the signature of defects in the structure of spacetime itself, colliding cosmic strings, leftover scars from the birth of the universe, releasing energy in a way no star ever could. He admitted he was just throwing ideas out. But that's the point. When a serious physicist starts naming cracks in reality as a candidate, it tells you how completely the ordinary answers have failed. There's a second, quieter possibility too, that Amaterasu wasn't a simple proton at all, but a much heavier atomic nucleus, heavier than iron. That would change the math of how it bends and how far it could travel, the kind of small detail that rewrites everything. And I'll be straight with you about all of this. These particles are real and measured. That part isn't a guess. But their source is genuinely unknown. Not hidden by anyone, not a theory someone's pushing, just unknown. If that uncertainty just made the sky feel a little less empty to you, you already know what the like button is for. Which brings us back to the question we opened with. Before the answer, one last thing nobody tells you. And it's the strangest number in this entire story. When that single particle hit the atmosphere, it didn't arrive quietly. It exploded into a cascade of more than 100 billion secondary particles, raining down across the desert in a sheet wider than a city block, all from one speck smaller than an atom. 100 billion fragments from one. That's the violence we're dealing with. Now hold that image, because it's about to mean something you won't expect. So let's answer the question. What happens the day a stream of these arrives? Here's the twist this whole video has been hiding. That's the wrong question. And the right answer is stranger than any disaster. A stream will never come. That's the secret I asked you to hold near the start. The thing that makes Amaterasu terrifying is the exact same thing that makes it harmless. It is alone. Whatever cosmic engine, or crack in spacetime, fired it. Fired one. A single bullet across an unimaginable distance that happened to thread the entire universe and strike a patch of desert humans had wired with detectors. The odds of that are so thin they barely qualify as odds at all. And that flips the entire story. We started this looking for a threat, something that could hit you, something to survive. But Amaterasu was never the danger. Amaterasu is a message. It's a single piece of evidence that somewhere out there, right now, there exists a force more powerful than every star, every black hole, every machine we have ever built. And it has left us exactly one clue. One particle. The most powerful thing the universe has ever shown us. It showed us once and then went silent. Which leaves us with a strange thought to carry. Right now, tonight, the same sky is over all of us. And somewhere in it sits a source of energy we cannot name, firing into the dark, almost never toward us. We caught one. We have no way of knowing if we'll catch another in our lifetime, or if the next clue is already on its way, crossing millions of years of empty space to land on a rooftop nobody happens to be watching. The universe sent us a single word in a language we can't read yet. The only thing left to find out is whether anyone will still be listening when it speaks again. If you want to be here when we go after the next thing the universe wasn't supposed to let us see, you know what to do.